Okay, so today we are going to look a little bit at some of the things that um, we've been talking about over the past couple of weeks, the t-test, the t-interval, and specifically we're going to take a look at one question that we have right here, and it's talking about textbook authors must be careful about the reading level of their book is appropriate for their target audience. So basically, you have a scenario where you're given a certain number of words, in this case 20 words, and we've counted the length of each word. Right, this word, you can get the reading level of a reading information that based on the length of the word, the level of reading is determined. So what we wanted to do was we wanted to make sure that our reading level matched up with what our goal audience was supposed to be. In this case, 6.5 letters was the word length or the goal for this reading level. So if we take that and you can pause this if you're reading along and you're kind of trying to work this out for yourself, go ahead and type that into your calculator and just kind of get the numbers crunched, and you can even do the test if you want to. We're going to kind of run through the whole process of what would it require to me to do a good job to complete this problem using the t-test. The first thing we talk about is writing our hypotheses, right? And so we naturally start off by saying our null hypothesis, HO, is equal to, well, the mean is going to be equal to 6.5 words. That's just kind of what they told us to start with. So we're going to assume that it is that, right? It's no different. I have no reason to think that it's any different. That's kind of what we do, the status quo, the absence of the desired effect. Our alternative hypothesis is going to be that the mean is just not 6.5. We don't really know if it's more or less because they didn't really give us an indication of where this is above the reading level or below the reading level. They just wanted to know that it was, if it's different than 6.5, then that's a problem. So they don't really care whether it's more or less. So we're going to take that apart. We're going to go with that premise and work that out. So to start with, we set up a null hypothesis alternative, and now we're going to check our assumptions. So the first part is randomness, and randomness basically says that we have a random selection of words. We have and in this case, they don't really tell us that it's random or not. It's not random. We have to make our own common sense judgment on this call. Random selection. Right? The next part would be independence. Although this one isn't really necessary because it's kind of automatic. Because a word, the length of a word, the length of one word would have absolutely no connection to the length of the word that comes before it. Okay, and so in that sense, if you left off independence in this particular example, then you wouldn't be docked for any points because it's kind of intuitive that this question really doesn't really apply here. It's kind of awkward to even consider that. What do you mean independent words from each other? So we're going to leave that one out. That doesn't normally happen, but in this case it would. And if you went ahead and said the word length of one word doesn't depend on the length of another word, that would be perfectly fine. Okay, the next part would be 10%. 10% says, well, I want to make sure that I have less than 10% of all words in the book. And we do. So we have less than 10%. 10% of all words. Right, and the last one is our nearly normal, and we need to really emphasize this because what I've seen so far is that not many people have actually done a good job of checking this. In order to do nearly normal, and I don't care if you're doing one sample or two sample, if you verify nearly normal, you will actually verify that with a graph. And so what we're going to do is we're going to graph the histogram, and you can probably hear the madness that's ensuing at my house right now. This is really not working. All right, so we have, let's see, we're going to start off with a minimum value. We'll put 0 here. And then 2, 4, we'll put 6 in the middle. 8, 10, 12, and 12. This is what I have to deal with every day. It's not always bad. So if you talk about, basically I'm just making a histogram of the word length of the list that we use in the calculator. So the first one, from 0 to 2, we just have one word, the letter A. And so we have this, and then from 2 to 4 we have 3. So we go over here. The next group we have all the way up at 8. So that's our big group here. And then the next two are kind of at 3, so 2, 4. So that's going to be here. And the last one is at 2. And so you can see in this case, this is, to verify this, we want to make sure that it's unimodal. And so definitely it's unimodal and reasonably symmetric. And so because it's unimodal and reasonably symmetric, then it passes the nearly normal condition. And so if we had, and then we have a sample size of 20 here, right? So n equals 20. If we had some slight skewedness or any presence of outliers, then we would have to have stopped this investigation because our sample size wouldn't have passed the nearly normal condition. In that case, that would have been a major issue, and we would have had to go on and do this again. And so we're going to go on and take our t-score. T-score is equal to negative 1.67, and our degree of freedom. And when you do a t-test, degree of freedom is something new, and so you're going to make sure to include the degree of freedom along with our t-scores here. Since our sample size was 20, our degree of freedom is going to be 19. And so 19 degrees of freedom, and I'm going to go ahead and put this in because this is going to be important a little bit later. Our standard deviation would be 2.685. And you can do this in one variable stats. I think this might even give you this at the end of the t-test. I don't exactly remember. And so we're going to go ahead and our p-value, so the p-value is equal to 0.1122. And this is obvious that if we have a p-value of 0.1122, then we're really not going to have enough evidence. So we don't have enough evidence. We don't have enough evidence to say that the average word number is any different than 6.5. Okay, and so this is the case, any different from 6.5. So we would fail to reject. We fail to reject because, I'm running out of room. Here we go. Because this right here, 0.1122 is greater than 0.05. And so we have an alpha level greater than 0.05, which is obvious enough room to say I failed to reject the null because my p-value is greater than my alpha level. And moreover, we don't have any evidence or don't have enough evidence to say that the average word number is any different than 6.5. So in this case, our results support that the average very well could be 6.5. Okay, the next part they talk about is they want to go into a little bit more accuracy. They want to get better, and in this case, they want to go in and talk about if I wanted to get within half a letter of the correct mean, if I were doing this, and we were going to create a confidence interval, then how big of an interval or excuse me, how big of a sample size do I need to go to in order to get that result in 98% confidence? Something to note, and you may or may not remember this, something to note is that when you are doing this in a t-score setting, we don't know the sample size, therefore we can't get the degree of freedom. So we have to assume, right, so to start with, we're going to use Z star to estimate. If we use Z star to estimate, then we can get a little bit better idea. And if you wanted to, you could even go back further and redo that at the end with a t-score, but not necessary. And so here's where it's going to be. We're going to say, all right, we want it to be within 0.5, so that's kind of like my margin of error. Within, whenever they talk about within something, that's always the margin of error. The Z star, so Z star for 98% is equal to 2.33. So we're going to use 2.33 times, and from back what we had earlier, remember our standard error, or standard deviation, was 2.685. So we're going to pull that back. 2.685. And we're going to divide that by the square root of n, which is exactly the formula for margin of error. If we work this out, now a lot of you have struggled with this, so I'm going to work this out step by step and showing you how I would do this in just the algebra portion of it. So we're going to divide both sides by 2.33. Right, so 2.33 here. That cancels, leaving me with 0.5 divided by 2.33 equals 2.685 divided by the square root of n. Now, I could cross multiply and divide by 0.5, but something to note is that I'm going to go ahead and convert this side into a decimal. And so we're going to do 0.5 divided by 2.33, and that decimal is 0.21459, which equals 2.685 divided by the square root of n. Something to note, when you have an equation that looks like this, what we want to do is we want to learn that what I can do is I'm going to rearrange this. Really what I'm going to do is multiply, cross multiply by using that kind of idea, but I already know how to get to the answer. Is I'm just going to swap this part, the n, the square root of n, with this part, because eventually if I work this enough times, I'll see that that's exactly what happens every single time. And so we're going to do it like this. The square root of n is equal to 2.685 divided by 0.21459. And if I do that, I get that that's really equal to 12.5121. That's still the square root of n. So if we square both sides, we're going to get n equals 156.55, which we will round up to n equals 157. And at this point, what we could do to get a better estimate, but this is not necessary, I could take my solution here using 157 and use inverse norm. I did not do a good job of getting all the distractions out of this video. I did not do this in terms of the solutions on the page, but I could use inverse norm using my sample size as 157, or inverse t, not inverse norm. And at this point, I would be able to get a degree of freedom of 156. And I could type that in, and if you actually did that, it would be this input. So inverse t, and we would use 0.01 because we're looking at 98% confidence. If you remember how we get that, if I talk about confidence, 98% is here. If I show you the areas, remember, I want to know the critical value, what number would represent this this t star right here, well, that would be where I have 1% at the bottom or 99% at the top. So we'll just use this one, 0.01 comma, let's see, 156 degrees of freedom, and that gives us basically negative 2.35. But remember, the t stars, we don't use them as negative values. So that would be my t star if I were to go back and try to re-estimate that. If you do that, you should end up with 160, which would be good exercise for you. Can you go back in, redo this problem using a different t star, and see if you can come out with the same answer I did of 160. You'd get 159.25, but whenever we look for sample size, the rule is you always round up. But just to be quite honest or clear, 157 is a perfectly acceptable answer, and that's what I would expect most people to have. But 160, if I used the actual t star, would also be a correct answer. Okay, it's a little more accurate, but not necessary to get that. So this is exactly how you would go through some of this stuff. Look back over it. I'll make this PDF available to you to download as well. If you have any questions, please re-watch or ask questions in class.